Hello viewers, welcome to the CA Foundation Paper 3 Business Mathematics. So let's start the paper with the chapter number 1 Ratio and Proportion. Today we are going to learn the topic Types of Ratio. Start 1. Inverse Ratio. 2nd. Compound Ratio. 3rd. Duplicate Ratio. 4th. Subduplicate Ratio. 5th. Triplicate Ratio. And the 6th one is Subtriplicate Ratio. You can see that there are 6 types of ratio. Now we will learn and understand all the ratios individually. So let's start inverse ratio. What is inverse ratio? One ratio is the inverse of another if their product is 1. Thus, A is to B is the inverse of B is to A and vice versa. So in the inverse ratio, if we multiply two numbers and we get its product 1, then we can say that the one number is the inverse of the other. Let's see its example. Inverse ratio of 11 is to 15 is 15 is to 11. And how is it possible? Here, consider A is equal to 11, B is equal to 15. So, first of all, we can write 11 is to 15 by 11 upon 15. So, 11 upon 15 into 15 upon 11, we get 1. Here we get its product 1. Therefore, we can say that 11 is to 15 is the inverse ratio of 15 is to 11 and vice versa. Next, compound ratio. What is compound ratio? The compound ratio of the two ratios A is to B and C is to D is AC is to BD. So, in the compound ratio, we have to do a multiplication of the first term of the both ratios and the second term of the both ratios. Let's understand its example. Compound ratio of 3 is to 4 and 5 is to 7 is 15 is to 28. And how is it possible? Here, let A equals to 3, B equals to 4, C equals to 5 and D is equals to 7. So by the definition, A into C. So 3 into 5, we get 15 and B into D. So 4 into 7, we get 28. So the compound ratio of 3 is to 4 and 5 is to 7 is 15 is to 28. Next, duplicate ratio. What is duplicate ratio? A ratio compounded of itself is called its duplicate ratio. The duplicate ratio of A is to B is A square is to B square. Now in the duplicate ratio, we have to do a square of first term and the second term. Let's see its example. The duplicate ratio of 2 is to 3 is 4 is to 9. Here, let's consider A equals to 2 and B equals to 3. So, we will do a square of A and B. So, A square equals to 2 square which is equal to 4 and B square is equal to 3 square is equals to 9. So, we get 4 is to 9. So, we can say that the duplicate ratio of 2 is to 3 is 4 is to 9. Next, subduplicate ratio. The subduplicate ratio of A is to B is under root A is to under root B. In the subduplicate ratio, we will do a square root of first term and the second term. Example, the subduplicate ratio of 16 is to 25 is 4 is to 5. And how is it possible? Here we take 16 as A, 25 as B. Now we will do a square root. So square root of A, it means square root of 16. So we get 4 and square root of 25. So we get 5. Therefore, 4 is to 5 is the subduplicate ratio of 16 is to 25. Next, triplicate ratio. The triplicate ratio of A is to B is A cube is to B cube. For more easiness, let's see its example. The triplicate ratio of 2 is to 3 is 8 is to 27. In the triplicate ratio, we will do a cube of first term and the second term. So, here A equals to 2, B equals to 3. Now, we will do a cube of A and B. Therefore, A cube equals to 2 cube which is equal to 8 and B cube is equal to 3 cube is equal to 27. So, 8 is to 27 is the triplicate ratio of 2 is to 3. Next, subtriplicate ratio. The subtriplicate ratio of A is to B is cube root of A is to cube root of B. In the subtriplicate ratio, we will do a cube root of first term and the second term. Example, the subtriplicate ratio of 27 is to 64 is 3 is to 4. And how is it possible? So, we will take 27 as A and 64 as B. So, take a cube root of 27 which is equal to 3 and take a cube root of 64 which is equal to 4. Then we get 3 is to 4. So, 3 is to 4 is the subtriplicate ratio of 27 is to 64. Next, note. If the ratio of two similar quantities can be expressed as a ratio of two integers, then the quantities are said to be commensurable. If we have some ratio, okay, and the quantities are said to be commensurable. When? If the quantities, suppose we have a ratio and it can be expressed in the integer form, then we can say that the ratios of the quantities. So, quantities are the commensurable quantities. Otherwise, they are said to be incommensurable quantities. Note, if the ratio of two similar quantities can be expressed as a ratio of two integers, then the quantities are said to be commensurable. Otherwise, they are said to be incommensurable. Let's understand this definition by example. Here, 3 is to 2 is expressed as the ratio of two integers. Therefore, 3 and 2 are commensurable quantities. Okay, we know that 3 and 2 are integers. Therefore, 3 is to 2 is expressed in the integer form. So, we can say that 3 and 2 are commensurable quantities. Next, under root 3 is to under root 2 cannot be expressed as the ratio of two integers. Therefore, under root 3 and under root 2 are incommensurable quantities. Here, we know that under root 2 and under root 3 are not integers. Therefore, under root 3 is to under root 2 cannot be expressed as the ratio of integers because they are not integers. So, the quantities under root 2 and under root 3 are incommensurable quantities. Thank you.